Hey, nice. Look at that. Welcome, everybody. I am so happy that you chose to be here at the end of the day. I can imagine that you all are pretty tired so far. But thank you so much. Welcome. I want to see some hands. Who has been here since yesterday morning? Whoa, look around you. That's pretty much the entire room. And who of you, the people that raised their hands, will be here until Friday? Raise your hand, please. Well, let's give a round of applause for that, please. Nice, very cool. Super thrilled that you are able to make it here. We are going to dive right in because we only got 30 minutes. I am Simone de Gijt and I come from the Netherlands. And my buddy Kotlin and I started working in IT from 2016 on. Kotlin got a big promotion in 2019 when he was promoted and announced by Google to be the preferred language for Android app developers. Pretty cool. But it was only till last year that I actually got to meet Kotlin when I started working for OpenValue as a Java consultant. So yeah, pretty happy with that. For today, we're going to talk about two plugins that are specifically made for Kotlin features. Both of them are there specifically to increase the code quality of your code base. First of them being Kover and the second one being Detekt. Now you might see that the structure is quite equal. Both will start with an introduction, a little bit of theory, and then at the end we have a little demo on seeing how you can actually use that in your own project. Now you might wonder what Kover is, or who Kover is. Laszlo Kover is a Hungarian politician, well seen and recognized by the moustache. Because I think everybody that goes into the Hungarian politician should have a moustache, and he definitely applies to that. Next to that, if you would go to the store here in Belgium or maybe in the Netherlands, and you would order a koffer, then you would probably get something like this. Because in the Netherlands, the word for suitcase is koffer. You write it a little bit different, but hey, who cares? But all fun and jokes aside, we are of course going to talk about a Gradle plugin for the Kotlin code coverage agents Jacoco and IntelliJ. Now, we have a few options. But before we dive in, I would love to go quickly over the basics. You probably all know code coverage tools, right? And if not, highly recommend you to go to one of the testing talks later in the next couple of days. But it's pretty simple. A code coverage tool calculates how much code has been reached by tests. And that calculation can be visualized in something like you see here in this class file. The green lines meaning that the code has been reached. The red lines meaning it hasn't been reached. And the yellow lines are for lines of code that have conditions in them. And if it's yellow, then it only has partially been hit. Now, there are some tools that can provide you that. First of it being IntelliJ IDEA. This tool works pretty well with Kotlin, I must say. Now, that's also not really weird because it's both Kotlin and IntelliJ are both, of course, being developed by JetBrains, so that makes sense. But unfortunately, we cannot, we cannot get the reports out of IntelliJ, making it impossible to integrate with our CI/CD pipeline. So that's not really nice. And if you're an Eclipse user or an other IDA user, then you're pretty much screwed. Now, another option we have is Jacoco. Who of you have used Jacoco in the past or currently? Yeah, most of you. Okay, awesome. Jacoco stands for Java Code Coverage, and that's exactly what it does. It calculates the code coverage for Java. But unfortunately, we are not writing Java, we're writing in Kotlin. And that brings some issues along the way. If we look at this class file, you might see that we have three methods. The first method being an inline function. Does this work? Oh, other screen. Yeah, perfect. Inline function. Second function being a standard greet without input parameters. And the last with a nullable string as an input parameter. Now, if I would execute a test that would call upon the greet method with a null as input, how many methods do we think that the code coverage should reach and cover? The answers are 1, 2, or 3. You can raise your hand if you think, yeah, just raise your hand with the fingers. Like, is it 3 methods? Is it 2 methods? Is it 1 method? 1. Any other? I see you are with a lot. Just raise your hand with something. 2. Okay, I think 2 and 1 battle it out. Now, the right answer is actually 3, because the test will go first into the greet method, which is the last method with null. Because it's a null, it will fall back into the second method, and the second method always makes use of an inline function. So it should have been 3. However, if we run Jacoco over this, you would get a report like this. First of all, it doesn't look as nice as the visualization that we just saw a few slides back. And that is because Jacoco doesn't know about the Kotlin directory structure, and therefore it cannot find the class file. Secondly, you might notice that the inline function has a coverage of 0. This is weird because we just saw that it should have been 3 methods, so the coverage should be 100. Now, this is because Java doesn't know about inline functions, and therefore it cannot calculate it or take it into account when it calculates the code coverage. But luckily, of course, we have a solution for that, and that is where Kover comes in. Some advantages of Kover are that it's been provided by JetBrains. It is well integrated with the Gradle toolchain. You can use it for multi-platform projects. It has some great Kotlin and Android features. It can test also your instrumented classes. It generates reports. And of course, it handles Kotlin very well. Now, you are here to learn about Kover, so I want to give you the full picture and not only the sunny side of the story. So we also have some disadvantages. First of them being that Kover was introduced only last December, and when JetBrains announced it, they stated it with the notification that it's only in experimental state, meaning there can be some bugs. However, I've used it in the last couple of months, and in my experience, if there is a bug and you report it to the project, they answer very quickly and they are very likely to do something with it, if that makes sense. Second disadvantage is that it's currently only available for Gradle, so no Maven support. If you are a Maven user, then unfortunately, either you sit this one out or you switch to Gradle. You can do that as well, of course. There is in the GitHub project, there is already an issue asking for a Maven support. So if you're very interested in the Maven support, please check it out, give a thumb up to the issue, and maybe they are more likely to pick it up soon. Now, let's switch to a little demo. Let me see. Yes. All right. First of all, you can see that I grayed out the Jacoco line. This is where we would normally find the Jacoco plugin, but I grayed it out because we're now going to use Kover. And with Kover, you can configure a couple of stuff. First of all, as I said, Kover supports the testing of instrumented classes. By default, it's on. It will take it into account. But if you don't want that, you need to specifically say so and put this to true. If you find that, oh, okay, you can just leave it out. It's not necessary, but just to give you the full picture, I left it in. Second of all, by default, Kover will use the IntelliJ engine. If you want to use Jacoco, you can do so by changing this to the Jacoco engine. Then some extra configuration for instrumentation classes and the reports that you want to generate. Now, I created a specific map or location where I want to get my reports because I find it easier to find, especially during a demo. But of course, that's very optional. Now, let's see if I can run this project so that we can get a report. That would be nice. Ta-ta-ta. The demo effect. All right, there we are. All right, go into my DevOps folder, which I created. Go to index, open it in my browser. And here you see the code coverage. If I would now go to my greeting service, which we saw before, you now actually see the nice visualization, which Jacoco didn't offer. And you can see that the inline function has now been taken into account. However, you might have noticed that it also takes into account some task classes, and in my org example, also the application. The task classes are being taken into account because I am using in my project an extra source folder, the iTest source folder. When you only use the test source folder, it will not take any tests into account. But however, it uses the iTest folder as if it would be a main folder, so we need to configure it out. Of course, we can do that. So let's go back. Let's uncomment these nice filters. And I now said that in my reports, I want to exclude all tests and application. If I would run that again, hopefully it goes a little bit sooner because it already did it. No, it doesn't. Ta-da-ta. We go now back to the browser, refresh, and you can see it is already gone. So that's pretty nice. Last but not least, when we have code coverage, most likely you want to have some verification rules on which the build will either fail or break. Here you go, da-da-da. So the verification can be assigned on multiple levels. You have line level, branch level, and you can state how much percentage your coverage needs to be. I am very ambitious, so my percentage is on 100% coverage. Now, I can also state already a kind of title or a description so that it's easier for me to detect what will fail later on. So if I now would build it again, then hopefully it will break, because we could see inside here that my branch coverage is 50, whereas I now expect a branch coverage of 100, and indeed it fails with the message, my minimal branch coverage rate in percentage is violated with a 50, where it should have been 100. So that is it when talking about Kover. If you have any questions so far, please write them down either in your mobile phone or on a note block or anything, because I would rather move on and see how much time we have left in the end instead of going over the questions now and losing some valuable time. So feel free to grab something you need. Okay, for now I need to get out of presenter mode, go back to my slides. All right, there we are again. The second plugin we're going to talk about is Detekt. And Detekt is a static code analysis tool for the Kotlin language. Well, that sounds pretty cool, but what does it analyze then, you might wonder. Detekt detects code smells. And code smells are considered bad practices. So in general, your code will still run. However, the quality of your code not so high. Your code has a lot of code smells. It is hard to maintain, hard to read, and hard to understand. So you want to avoid that. If we look at an example, you see this code here, and we see an if statement with 4 conditions. If we would run detect over this code, you would get a complex condition issue because the rule has been violated because the maximum amount of conditions within an if statement is set to 4. And at 4, the rule will go off. So in this case, it goes most definitely off. Now, just as with cover, we have again a few options. First of all, being SonarQube. We all, or not we all, but lots of you will probably know SonarQube. It's very well known. It generates beautiful reports. However, it's quite big, and that's an advantage because it has a lot of options. On the other hand, it's also something you really need to dive into and less plug in and play as Detekt would be. So you need to make out the pros and the cons for yourself. Some very nice thing I learned yesterday evening from Twitter is that Jeroen created a very nice project where you can integrate Detekt with SonarQube. So if you want to combine forces, then that's definitely the option for you. In the sources, I have stated his GitHub project as well, so you can check that one out. Now, a second option would be Mega Linter. It's free, but it's not Kotlin specific. So, meh, also not great. Now, if we look at Detekt, it has, again, some advantages. First of all, it is very configurable. That will say the rule set and the quality gates. Now, I must admit that I'm not too happy about it, but when it comes down to code smells, it is often very subjected to personal preference and personal taste. If I would put 10 developers in a room and would ask them to create their own rule set, it would probably become quite a mess because everybody has his own opinion and finds something very important or less important, blah, blah, blah. So in that sense, it's quite nice that Detekt offers a way for us to configure it to our liking and to our project's liking. Next to that, it can be configured with a lot of other integrations. And last but not least, it can be integrated with Kitty-lint. Now you might wonder, what is Kitty-lint? It is not a linter to clean your cat. I thought I should have a cat meme somewhere in my presentation because, hey, developers. But it is a linter to check your code on the code styles that Kotlin has generated. And with that comes also a formatting tool. So if we would look at this example, you have some wrong ordered imports, some spaces are missing, wrong annotation. And Kitty-lint is the tool that will both detect it and will format it if needed. Now, Kitty-lint is its own plugin, but with Detekt you can also use it combined. So that's pretty nice. Now, to be honest, I promise you some advantages and disadvantages. So far, I haven't found a lot of disadvantages. So we're skipping right to the demo. Let's take a look. Back into my presentation mode, switching projects. Yes. All right, here we go. The build file, where everything starts. We have here again the Detekt plugin. And as I said, we also have a Detekt formatter. This is the Kitty-lint plugin that's provided by Detekt. Now, if I would go to my service class, you can already see here that I've implemented the same code that we just saw with the 4 conditions, being the too complex condition. So this should run into an issue whenever I would start building. Now, that went quick. We have actually 3 weighted issues. They are, of course, stated in my terminal, but I would also like to see them in a report. So we're going a little bit up. Inside our build, we will find a report, open it, and here you can see a report with some complexity, details, and then the issues that Detekt had seen. Now, this is very nice, but I don't like the fact that I need to wait until I build my builds until I see the issues. I would rather already see it, right? Like the sooner the better. Luckily, we have also a solution for that. There is a Detekt plugin that you can download, and that will make sure that you will see the issues already in your code. Don't forget to configure it underneath tools. So you need to enable it. By default, it's already enabled. And you can configure yourself if you want to see the issues as warnings or as errors. I have it as warnings. And if you have that specific dependency added to your dependencies structure, then you can also enable those. So if I would now apply, we can already see that here I'm missing a space, which would be my KT-lint issue, and here we have the complexity condition. Now, just as I said, a lot of developers, a lot of opinions. Maybe my team says, 4 conditions? Nah, that's fine. I can understand 4 conditions. That's not complex at all. And they might want to configure it in a different way. Now, this is where the configuration comes in. Within Gradle, Detekt has provided you a Detekt generate config file. Whenever you run that, Detekt will generate a config file for you, which will get into a config folder. Makes sense. And when you open it, it will hold all the issues or all the rules that Detekt holds. Now, if you want in the future maybe to create your own rules, they will also be added to this file. When we would look at the report, you can already see at every sort of title, we can already see what's going wrong. So if I would now search for the complex condition, I can see here that it's currently active and the threshold is 4. If I would now change that to 5 and I would run my build again, we would hopefully see that we only got 2 weighted issues, which is shown in the terminal. Now, you might have a project that you already worked for for a long time, and you have tons of code smells when you run it for the very first time. Now, you don't want to fix them all at once, and you want to kind of start from a clean slate. You can, of course, do that by adding the Detekt baseline. Whenever you run the Detekt baseline, it will generate an extra XML file over here, and when you would now rerun the not the baseline but the build, then it would just be left out. So, also a great solution when you want to do that. Now, as I said, you can add your own rules to the rule set. If you want to do that, Detekt offers you a very nice template by which you can create your own code. And then whenever you have generated the code, you add it to the config file, and then it becomes part of that. So that's pretty nice. Last but not least, when we're talking about KT-lint, this is just a short thing I want to mention, is that with KT-lint, you can also, of course, decide to only use that. You have also a separate dependency or plugin for that, which would be KT-lint, and then you can download that as well, which makes it, again, a little bit nicer to format and to view. Now back to my presentation. Oh, I forgot to get out of presenter mode. Cool. Now, this was the demo. Awesome. So as I said, these are some of the sources and the GitHubs and like READMEs that I've used for this presentation. As I said, the Sonar Kotlin one, which is the fourth in the row, is one to integrate your detect reports with your Sonar Cube engine, which is pretty nice. And with 5 minutes on the clock, I have time for questions, if there are any. Are there any? Oh, yes. With multi-module project. Yes, I've tried it. It does require a little bit more configuration to get them together. I tried, so I need to be fair. I tried it with Kover. I didn't try it with Detekt. So I'm not sure about Detekt. Oh, it works. Thanks. Cool. Nice. Any other questions? No? Okay. Well, enjoy your free 5 minutes. And thank you so much for showing up. And enjoy the rest of DevOps. Thank you.